article today.
Oh, thank you. Very good. Very good. Very good. Good, good, good. Uh, are we ready to start, Chitra?
Sir, no, 1 minute.
Okay. Sonic, you not responded to me, I think, on this thing that you want to do for John Turner, huh?
Yeah. I'll respond this week. Actually, I was busy with this this Marcos meeting and all this. So with the proposal for the book, so I have in that in mind. I'll respond this week.
Yeah, please,
Saturday
because
also.
I think you know, see,
Yeah, sure,
uh,
sure.
my friend from England goes on reminding me, and he feels that I'm delaying it and I'm waiting.
No. I'll respond this week.
Okay.
Sir, we can start.
Okay. Thank you. Thank you, Chitrakshi. Chitrakshi, please remind me not to forget you when I do thank you. Friends and colleagues, it's my privilege to welcome you to the fourth episode of the 10 part new webinar series focused on INHAF's project in Chennai called Climate Chennai. Today's subject area is urban heat island effects. The earlier three episodes covered urban flooding and extreme rainfall, then COP28 that took place in Dubai recently, and cities and climate change. We already have finished three, and this is the fourth of the 10 event webinar series. This new series focuses on what climate change means to the cities. How will it impact their day-to-day business? How would they affect living and working of the cities, citizens, especially those of the vulnerable communities? Planning, growth, and future development. All of this will be affected by climate impact. Also, how cities contribute to climate change and what needs to change for cities to be more prepared to meet the climate challenge. To understand cities' relationship to climate change is enough to say that the world's cities occupy just 2% of the land mass, but consume 75% of its resources and throw 75% of the waste in the environment. And there is no global or overall sustainability without urban sustainability. That's the importance of cities and urban living in the context of climate change. INHAF's project in Chennai is a modest effort to understand the phenomenon through a detailed case study of a city. We have taken Chennai as a case study to understand how this will impact cities and what should cities do in terms of meeting the climate challenge. Unlike other webinars in this series by INHAF called Rethinking Cities, which has completed more than 100 episodes in 3 years since the pandemic lockdown, this webinar series has a special connect. It is an integral part of an INHAF project and is meant to do four things. One, introduce the project to Chennai city. Two, to learn more about Chennai in context of its preparation to meet this climate challenge. Three, know institutional, organizational agencies and individuals working on different aspects of climate challenge to learn from them and strengthen their effort in the process. And four, make contribution to the extent possible in developing mitigation, adaptation, and resilience strategies, contributing to city evolving strategies to reduce carbon footprint is a very important objective of this effort. And to find workable ways to decarbonize the city. The project sees Chennai as a microcosm of the big global climate change phenomenon and hopes to contribute to solution making in the local context involving local knowledge, local resources, and local skills. It is an action project by a small civil society organization and is meant to take the climate change phenomenon to common citizens and help them prepare to meet the challenge head on. This to us is very important that the climate challenge, the climate phenomenon must reach people and must reach people effectively so that they understand and so that they are able to contribute. Dr. Raghunandan, who is leading this project and is also moderating this webinar series and is a distinguished panels he has today, they will tell more about this whole phenomenon than I could. However, before Raghu Saabji takes over to conduct this session, it is my task to tell you why is INHAF running this webinar series for such a long time and what it aims to achieve. The underlying rationale or the governing hypothesis for this webinar series is that we as a country, we as concerns institutions, its experts, specialists, and professionals, and also its governments, have not been able to read the nature of the urban challenge properly. And this is very important. What one is saying is this, that all of us have not really understood the urban challenge properly. Both its positive potential in terms of what it could do if handled properly, if managed well, and its negative consequences if we are not able to do it properly. And therefore, the response to it leaves much to be desired because we have not done it properly and seems to lack direction and purpose, both in its immediate context with regard to quality of life of the people and the exploration of its future potential. Urbanization obviously has a great potential, no one can deny that. The cities as they are, as they grow and develop, seem to convey that things are not what they should be and need an urgent, what I call re-see, rethink, and react in policy, in program, in institutions, and investment. There is an unspoken, unseen, and unarticulated silent emergency and the missing urgency and creativity in response is causing harm in economic terms, in environmental terms, and in human terms. So this narrative is certainly not to run down or harp on the inadequacies or in any way take away from the importance of the development and investment programs in our infrastructure and basic services that are taking place. It is an effort to argue the case, to put forward a difficult to make the point that meeting the urban challenge effectively requires more than the current efforts and investment. We need to do more. It requires something more and different. And what is that? Thinking out of box, non-conventional approaches and imaginative strategies and different kind of solutions, because what we have do not seem like working. In approaching the problem and finding solution, it requires a different mindset, a paradigm shift. Even if this looks a bit of an hyperbole, we believe very strongly that urban challenge requires all these things. A broad-based societal partnership, and we are not only saying this is what the problem is, we are saying how to go about doing it. You said a broad-based societal partnership is the conceived way of doing this work, mobilizing societal knowledge and resources, and utilizing skills, domain expertise, and experience of subject experts, professionals, specialists, researchers, and engaging the interested and concerned institutions and agencies in a working partnership in search for the new approaches and new solutions is the envisaged organizational model for this work. We say all this must happen. This webinar series is a part of a wider national societal effort aimed to bring in not only fresh ideas and perspectives, but also new voices, new collectivism, new togetherness, new partnership, and new energy in articulating the need for and ways to rethink our cities. Rethinking our cities, we consider, is absolutely important, both in terms of redefining the urban challenge and finding more effective ways to addressing it. This is taking the urban challenge to the people. This is operative part, taking the challenge to people, is preparing them to engage and contribute, second part. And it's making the urban development challenge a societal challenge, a people's challenge, along with that of the government. Beyond a century of episodes and still going strong, we are also reflecting and assessing as to how well we are doing on the objectives of this initiative. We are reflecting and trying to find out, now that we have done 100 webinars, whether we are doing it correctly. And it appears to us that the idea obviously has strength and impact potential. But we need to be more innovative in addressing matters and getting right people on this platform. So that is our learning. And as a matter of fact, the new departure from 100 webinars, where we are concentrating on this 10 Chennai related webinars, is reflection or response to that particular understanding. So with this introductory note,
Sir, we can't hear you.
Kirtibai, that last part we couldn't hear.
no, fine, leave it.
Okay.
I'm requesting you to take over. Please do that.
All right. Okay. Great. Hello, everyone, and welcome to this webinar. This is the fourth in the series of our this present series on cities and climate change with a focus on Chennai. Having said that, we've got participants here, speakers who are experts in their own fields, with stellar backgrounds in the subject of urban heat. So I'm not going to preempt their presentations. I will only say that the format of our webinar today will be the same as we have been following for the past three webinars, which is that we have experts from their own fields, from different parts of the country, not necessarily from Chennai. So although our webinar series has a focus on Chennai, we would like to have a pan-India view, as well as views from different cities, so that we learn from each other as to what is happening and what we need to do, both in city-specific terms, as well as perhaps on a pan-India basis, which would have a reflection on what happens inside the city. So I will only make an initial, very brief presentation on framing some issues for the discussions to follow. As I said, I don't want to preempt any of the speakers. Each of them would follow their own expertise, background, interest in putting forward their perspectives, the problems that they see, and potential solutions or responses to that from their own perspectives. And they are completely free to do so. I am just putting this forward so that perhaps either the speakers themselves or during the discussions to follow, we will get a chance to discuss some of the larger issues which while studying the problems of climate change and urbanization in Chennai city are confronting, because we confront a set of problems and issues both at the city level and at a national policy level of etc. So I'd just like to frame some issues which these speakers may like to address, or which we may perhaps get a chance to take up during the discussions. Next, please. Yeah, so this is just for viewers, participants who are not very familiar with the notion of the urban heat island. Very briefly, the urban heat island, or UHI, is when temperatures in the city are higher, and the speakers will tell you this ranges between, say, 2.5 degrees Celsius to perhaps even up to 7 degrees Celsius, more than in the surrounding rural areas or the hinterland. And this is largely due to many factors: concretization of the urban space, the buildings, impermeable surfaces, asphalt which is on the roads, the great amount of exhaust heat which is generated by air conditioners, vehicles, industrial, commercial equipment and machinery, and the blocking of winds which take place because of the high-rise structure of the buildings in urban built environment. With these, the urban heat island is a very urban-specific climate change problem. In the previous seminar, we discussed urban flooding, which is also quite specific. There's rural flooding as well, but urban flooding has its own characteristics. The urban heat island is very typically urban, and it requires special discussion because it has intimate relationship with urban form, urban planning, all the issues that Kirti Bhai was just raising. Climate change adds to this problem of the urban heat island, because as the IPCC and others have pointed out, we are likely to see more intense and more frequent heat waves due to climate change. Now, if we have more heat waves, which means that your temperatures are 3 degrees, 4 degrees higher than what they used to be for longer periods, that poses a danger. In high temperature areas like India, and especially in coastal areas like Chennai, which has got high humidity also, and Chennai has temperatures of 40 degrees Celsius plus very high humidity, a measure which combines temperature readings and humidity is called the wet bulb temperature. And the WHO says that if the wet bulb temperature crosses 35 degrees Celsius, which is roughly equivalent to a dry temperature of 40 Celsius, this is close to the limit of human survival, meaning that we are at a serious threshold of crossing a level beyond which there is likely to be far greater morbidity and even mortality in heat waves, given the already high heat threshold which is caused by the urban heat island effect. And this means that we need response urgently in India, which we haven't seen so far. Next, please. Yeah, so I'm sure the speakers will address the specific issues that I was speaking of, and also which were picturized there: the impermeability of surfaces, the lack of moisture in the urban environment, which could have, both by releasing the moisture, cool down, as well as absorb more heat into it. All these other reasons I'm sure they will talk about. But what we know and can see is that this is a multi-dimensional problem. It touches on buildings, it touches on roads, on vehicles, on green spaces and green cover, on machinery. If we are to address all these, I believe that a piecemeal response, let's just look at buildings or let's just look at roads, will not suffice. You need a systemic approach. And this is exactly what I think Kirti Bai was talking about. We need to view urban development in the context of climate change, given the hot and humid weather in peninsular India, the high heat temperatures in the northern states. We need a different approach, a different systemic approach towards a planned, climate resilient, and sustainable urban development. We need to think of this holistically and find a different way of addressing the problem of urbanization. Next, please. And in the Indian context, there are several policy level as well as institutional issues that arise. Of course, we know that actions to address the urban heat island would be city specific. Chennai being a coastal city would have certain characteristics. Delhi being in the North Indian plains, which have certain characteristics and so on. But I'm sure this will come through in the presentations we are going to see and hear. There will be several common features. One question that comes up is, can cities address these issues on their own? Because there would be limitations of capacity, limitations of governance structures, and limitations of finances. Nowadays in India, the imbalance of finances between the union government and the states is very much under discussion. And within states, how much power city governance has is also a big problem in India. So keeping all this in mind, how cities address these issues are also affected by these institutional and capability and financial issues which arise in India. So one of the proposals which has been suggested is, there is a national heat action plan that we have in this country. Do we need to modify that in order to include the UHI as part of that national heat action plan and modify the heat action plan to suit that? Or, like we have discussed in our earlier webinar also, as well as in the introductory one, do we need to take an even broader perspective and look at urban heat island, not just in the context of a heat action plan, but as part of a larger national urban climate action plan? So we've got plans for urban development, you've got plans for urban housing, you've now got a plan for clean air, etc. Do we need to have a more integrated and holistic urban climate action plan at the national level? Or do we take an even broader view and say that all this should be part of a national adaptation plan, which India still does not have? The bulk of our NDCs, which we have submitted to the UN Framework Convention on Climate Change, are to deal with mitigation issues. Adaptation issues we have taken up again on a piecemeal basis, but we are yet to formulate a national adaptation plan. And I believe in the months and years to come, there would be increasing pressure on us to develop such a plan and even to submit it before the UNFCCC in the coming COPs. So I've just laid out some broad issues which I think would come up, and maybe we will discuss them at the end of the seminar or of the webinar. And maybe some of the speakers during their presentations may like to touch on these issues as well. I'll stop there and now call upon our esteemed speakers to make their presentations. I will first call upon Dr. Jayanarayanan Kuttippurath from the IIT Kharagpur to please make his presentation. Dr. Jayanarayanan.
Yes, sir. I hope you can see my.
Doctor, about 15 minutes. Okay, and would you like me to give you a reminder at about 12 minutes or so when you've got a couple of minutes left?
That would be fine, but I will finish in 15 minutes.
Great, thank you.
Okay, thank you very much. And it was a nice introduction to the subject and the webinar. Thank you very much, sir. So today we are talking about urban heat island and its past, present, and future. And we have already given an introduction about urban heat island. So I'll be briefly touching this subject. It's a phenomena in the urban region that experience much warmer temperatures than its nearby rural region. For example, here on the right side, you have a picture here. And you have also land surface temperature, night and day. And if you look at the built-up area here, downtown, there are high temperatures as compared to the rural region. And this is called actually the urban heat island because the urban region acting as an island of heat source. And what are the reasons for that? That means there are heat sources or there are materials that emit radiation heat. That are low reflective materials, impermeable surfaces, high density thermal mass, for example, buildings, urban canopy, wind blocking, dark surfaces, and lack of vegetation, air pollution, high use of AC, and indeed climate change can also contribute to UHI. And the question is, what are the impacts? Why we want to study this or why we are worried about UHI? Of course, it's danger to human health, public health, and it's also provides heat stress to animals and aquatic systems, and we have to use more energy because we are running ACs or fans. There is more heat then, and then affects water quality, and there are more GHG emissions, for example, carbon dioxide and air pollution as well. And of course, the secondary impact is it adds to global warming because it increases temperature and also to climate change. So here on the right-hand side, there's a figure showing all 4 metro cities in India. It's a land surface temperature you're seeing here because we are using land surface temperature from satellite for calculating UHI, Urban Heat Island Index. And the bottom panel shows the Chennai city, and we have the highest temperature in summer, of course, and then in monsoon season, and the lowest in DJF, that December, January, February in winter. So if you take this urban region here that's shown in this outline and the rural region beyond that in color, and you subtract this rural minus urban or urban minus rural, then you will get UHI, that's UHI index, that's shown in this picture. And it's in all 4 seasons you have here in the summer here, and then DJF winter, JJS monsoon, and then October, November. And in the background here in a map, in summer, you have the road network, and then here the city map in here, in the left top, and then here the urban built-up area. And here in the population of October, November, in the background, you have the population density or how much population is there in the city. That means if you look at the UHI, it's different in different regions. You can see, for example, here in the bottom panel, in October, November, we can see that high population is here, and then UHI is also high. And as compared to the west or some other regions like the far north. So there are regional changes, there are regional seasonal changes, and there are hotspots like this. And if you look at this, there are more built-up areas here in this region. So you have more UHI there, and also cold hotspots. And there are also cool islands. Some region you can see that blue and green region, those are called cool islands where you have lower temperature. So if you do this for example, here you have 44 Indian cities shown in this picture. This for actually 2017 and different seasons and also for annual data here for the seasons, winter, pre-monsoon, monsoon, and post-monsoon. And this is annual for 44 cities in India, and this is Chennai. And these are the values of UHI index, day and night, in different colors, day and different symbols for night. You can see that these EHA values are around 1 to 2 degree because it is average. Okay, it's average from 2003 to 2016 values. So that means there is increase in heat in the city of Chennai. And we have also found trend. That means you take the values for each year from 2003 to 2016 and then find the long-term trend. And then you have value something like 0.044 per decade, degree centigrade actually. And in summer and 0.31 degrees centigrade per decade in winter. That means year by year, this is increasing by this 0.044 degree per centigrade per decade, or in winter 0.31 degree per centigrade in decade from 2003 to 2016. So that means this UHI is increasing. So what's the reason for this? Here comes urban sprawl. That means the urban region is expanding beyond its current boundary. So two pictures are here in the left and right, A and B. Here 1998 land use pattern is shown here, and 2019 land use pattern is shown here. The different colors represent, for example, here green is natural vegetation, and then water bodies are green, crop plants are brown, and then open lands are this, and then shrublands are even like this. So that means if you compare these two pictures, you can clearly see that this city area is expanded like this, and there are load of urban expansion in the western side as well. So city is expanding like anything. Population is increasing. That means the built-up area is increasing and infrastructure is increasing, and city is expanding to beyond its boundaries. So in this picture, it is summarized like in the left side, you can see that this is the urban development, urban high development, medium development, and low development, three classes. And here this wetlands, croplands, and open lands and fallow lands. That means these lands are losing there, but urban regions are increasing. The urban land space is increasing. That means we are losing the wetlands, the water bodies, and the croplands, open lands, and fallow towards the urbanization or towards the urban land. And you can also compute these values with respect to this enhanced vegetation index from satellite. This is for Chennai. There are all 44 cities are there. And if you look at that, and all season, if you look at the EVI, this is decreasing. It is also found just like VHA, the urban or rural minus vegetation. It's showing that the vegetation cover is decreasing in the city. And actually, it's not about only the heat. If you look at this UHI in Chennai 2019, and there I have selected two regions. One region here, high UHI, and this relatively lower UHI here. And these two regions also, you can see this region is highly populated, and there are more built-up area. And here you have open spaces and vegetation. So the difference you can clearly see that high, dense built-up area, you have higher UHI, and this region where you have more vegetation, water bodies, and trees, and you have relatively lower UHI. And this in the middle panel, actually, I'm showing the aerosol. Actually, this is aerosol optical depth. It's a unit of that. And you can see that wherever you have high population or high activity, you have also high pollution there. So it's not only about the activities there towards the heat, but there is also pollution, simultaneous increase in pollution in the city. That will also contribute to UHI. I will tell you that later during the discussion. So we have a problem, and then we have to find a solution. That's one is mitigation. So what we can do about it, we have to have a cool or green roofs, more vegetation, green building, green parking spaces, and of course we need policies. And more importantly, we also need awareness programs about UHI and its adverse impact. And you know that many people, they don't know about UHI and its impact, or how they contribute, or how they can also mitigate the UHI effect like that. So we need awareness programs such like the same as you do today. So we need solutions for this, and we can also look for nature-based solution. It is the best and long-term, and it will seize the momentum of change. And it will also make awareness about the value of nature, and there are also economic gains for that. And if you are going for trees, this is one aspect of the solution. You plant trees, more vegetation like parks, forest, and street trees. but tree selection is very important. So if you are talking about trees or vegetation, if you look at this left-hand side figure, you have suburban area or rural region or park. You have more vegetation there, more trees or plants there as compared to the urban commercial or urban residential area. And you have higher temperature here and relatively very high temperature here in the commercial urban region. That means the trees can reduce the heat. Here is another example with Chennai itself, where you have the UHI here in Chennai in different parts. And I have selected 3 different regions in Chennai. And you can see this high dense building structure here in this region. It's not the whole region, okay? It's only a selected region in this circle. Similarly, a selected region in this circle here, that's mixed building and vegetation there. And here, there is no building at all in this small region here. So you can see that if you have more built-up area and there is no trees or open space or shrublands or croplands, there is only buildings, then you have very high UHI as compared to where you have more trees or mixed trees and buildings there. So that means one of the ways to mitigate UHI is the trees, which will reduce urban heat island, reduce urban particulate pollution because trees can also take it, and it will also reduce runoff and will increase infiltration. And another way to do mitigate UHI or the temperature is installing green roofs, installing cool or mainly reflective roofs, and using cool pavements. You can also see different pictures how it works. So that means nature-based solution to maintaining green cover and increase green infrastructure may help cities to maintain sustainability. And there is a question: what about eco-cities? Because that's one solution. Because eco-cities where people and nature live together, and everything is run by everything is nature-based. So eco-cities is a solution for that, but many of our cities are not planned, and we can plan smart cities, but there are ways to do that, but not completely driven by technology, but there are smart technologies that can reduce emissions, that can reduce heat as well. So in this aspect, why do we need a policy? So if you look at this picture, if there are 2 situations, you have a policy situation, and that means you do not touch natural land or wetlands or crop, or business as usual, BAU, that whatever happens now, it will continue. That means in that situation, BAU situation, by 2050, we will lose 150 square kilometer vegetation and 302 kilometer square wetland and 43 kilometer open land. And which will also give you an urban area of 5-10 kilometers. That means all of this will be lost, but if we lose that, means that will also increase the temperature. So we need to do something about that. So this is a projection, a model projection for the same region here, and these are different land classes. That means natural vegetation and urbanization, and that means low, medium, and high in all these red, and then water here and croplands. So if you look at this, the first policy scenario is agricultural, natural system, and wetlands transitions are constrained. We don't touch that much. And the second is business as usual. No constraints are applied. So if there are no constraints, you can see high urbanization in this region. So that will increase heat burden, that will increase pollution load, and increase of impervious surfaces, impacting water security due to increased runoff and lower percolation into ground. So we need a plan, we need an action plan. So already we were talking about heat action plan. Actually, there is a heat action plan, but this is only for a extreme heat warning system, that for improving public awareness and community outreach, facilitating interagency coordination and reducing heat exposure and promoting adaptive measures. But there is no action plan specifically or exclusively for UHI or urban regions or urban heat island. But there are regulations or awareness for green infrastructure, climate resilient buildings and roads, energy efficient infrastructure, and so on. So now all these can also contribute to reduce UHI effect. So this was actually first chapter in Ahmedabad city, and the warning system mostly focused on extreme heat, which is based on air temperature, not land surface temperature. So similar system can be also developed with respect to land surface temperature and also for EHI. So there comes the sustainability. So we have a problem and we need a solution for this. We need policies, and then comes the sustainability. Then there is already a report in government using all 17 SDGs, from no poverty to partnerships for the goals. The 11th one is sustainable cities and communities. So they have classified different cities according to all these 17 SDGs, and Chennai is in front runner category. There are other categories like aspirant and then performer, then front runner, and then achiever. There is no achiever yet, but many cities are front runners, many are performers. So we need improvement. That means if you look at Chennai city, all 17, and this is the 11th one, SDG about sustainable cities and community, and its rank or this score is 50. So there is much to improve for Chennai. And if you look at the rank of the Chennai in terms of sustainability, it is in the 11th position. It's not much better than many other cities in India, particularly the metro cities. It's good, but still we need a significant efforts to make the city sustainable. And so we are talking about the different plans, different problems and other things, but one important thing is participation of people, public. It's very important. It's not about the local administration or state government or central government, and people, active participation is necessary to have a sustainable city. With that, I will stop here and then we can continue the discussion. And thank you, INHAF and Climate Action Chennai and all image providers and my parent institute, Atmos Coral and IIT KGP. Thank you for your kind attention.
Thank you so much.
Professor, before you say anything, let me thank you profusely, because in your long presentation, you did not go a word beyond Chennai. Everything was around Chennai. So thank you very much. That particular focus is very important. That is what we're trying to do, and that is what we're trying to learn. So thank you, Professor, very much. You taught us so much today. Thank you.
Thank you, sir.
Thank you. I'll next call upon Dr. Lilirose Amirtham from SPA, School of Planning and Architecture, Vijayawada. She's a multiple award winner in a variety of contexts. She's done a lot of specialized work on urban heat, and she's a former graduate from Anna University, SPA. So somebody who is by context and otherwise extremely familiar with Chennai. So Dr. Lilirose, to you.
Thank you, sir. I just present my screen now. I hope my screen is visible.
Yes, it's fine.
Yeah. Good evening, one and all. As our previous speaker was speaking on urban heat island, I would focus more on, as Dr. Raghunandan was saying, it's a coastal city, Chennai. As he mentioned that I graduated from Anna University, my research area was urban heat island effect and thermal comfort with a focus in Chennai. So I would be just briefing through that. So basically, the climate in urban areas are modified by physical form and composition, and also the urban activities, which results in a unique climate type that is defined as an urban climate. And in order to give a brief thing, when you talk about the difference between urban and rural air temperature differences, it is the temperature difference. You can see that the temperature difference between urban and rural, it is basically in the night time, which is evident clearly, but there is a very minor variation during daytime. So that is basically, that clearly indicates the intensity of urban heat island. So here, when we talk about UHI at the city level, most of these aspects like geographic location, city size, time and synoptic weather are little difficult for us to control. But then when it comes to mitigation, it need to be mostly focused on city form and the city function. So city form is basically defined by the building geometry, the materials that we use, and the land use, land cover strategies, and also the city function, which focused on the equipments that you use which releases anthropogenic heat. So if we can focus here, it is more easier to mitigate the UHI. So here on this UHI is there in different scales. So like we have it from city level to neighborhood level to street level. So the city level, for all this, if we focus our study mostly on the street level, where it depends on the absorption of solar radiation at the canyon, which is basically the street level, the materials, the permeable surfaces, the sky view factor, the unobstructed view for radiating during night, because nighttime accumulation is what is defined as a urban heat island. Then the anthropogenic heat. So these are our focus should be more at the street level, so that would reflect at the neighborhood level and at the larger scale at the city level. And if you see these urban heat island studies, if you see there are different levels at the city scale, the boundary layer urban heat island, wherein it addresses, it can be done both at the city scale and the neighborhood scale. The canyon level is basically at the neighborhood and the street level, and surface urban heat island, which is basically the LST, which again can be done at all three scales. So here, I just would like to present a few studies which were done on Chennai. So the Chennai study, which were the typical climate, but this is little old study, but then still, if you can see the nighttime discomfort, which was comfortable for about 8 months in Chennai in 1980s till 1980s, have increased now that the discomfort has come to about 7 months, which would be still even more now. It would have just reached around 9 months if we had just done this. Then we can also see that is at the city scale, basically analyzing the meteorological station, the linear trends, and the surface urban heat island, basically that also states that the land surface temperatures are increasing over years ranging from 1991 to 2006. And we can also see these studies can be done at different levels. So if we can do by means of field measurements in situ, and then also through mobile survey. And these are some of the trends that have been observed here, and which this was done in the year 2008, but then subsequently we have also done in 2017, wherein we have found that there is a difference. During hottest months, it ranged between 3.6 degrees Celsius, and during the coldest months, the range was around 4.1 degrees Celsius. This was only 1 year; it is not a cumulative of different years. And we have also done kind of a mobile survey, wherein we traversed across the city and tried to interpolate, and we could find that as we go away from the city. So this is a typical UHI profile of Chennai. This was done in 2017, and we can see the temperature. This is done during a winter season, and we can see the temperatures at the rural, which was around 20.3 degrees Celsius. It's almost around 4 degrees. There was a difference between the rural and the urban areas. So, and similarly, the surface urban heat island also gives a profile here. This is basically the profile of 1991. When it comes to 2006, you can see a significant increase in the temperature. As the temperature is also increased, and the profile is also, even the lowest temperature is higher than that which was found in 1991. And there's a difference between the surface temperature and the street level. This canyon level urban heat island is basically focusing at the street level. So the street level, if you see, there are not much changes throughout this. However, in the city, there is a significant in this. This is basically during summer we are able to witness because of the concrete jungles in the city, which rises the surface temperatures, and in turn elevates the air temperature near the streets also. So these then at the neighborhood level, again we can study these in terms of there is local climate zone approach, which focuses on different densities of built environment. So these measurements can also be focused at street level through simulation. This is again how the street geometry works. So I'll just show you one detailed research, wherein Here, this study was done based on local climate zone, wherein the built form is divided into 10 different characteristics based on the density, and the natural form is classified into 7 classification. Here we try to analyze the building regulations on outdoor comfort conditions, because just analyzing air temperature and just analyzing UHI intensity is not sufficient, because it will have an impact. The temperature and humidity together has an impact on comfort conditions. So we try to analyze the outdoor comfort conditions here to understand the severity of the heat island and its impact on the outdoor thermal comfort. Here basically the Tamil Nadu building regulations 2019 were taken, and we try to understand with the increased FSI, basically the urban planning guidelines at city level, to optimize the built form for recommendation at the neighborhood level. So here, if you see, there are 3 locations that were selected for the study, and then we analyzed 3 different scenarios. The first scenario was the development regulations, which were in practice up to 2030. Then the case 2, where we tried to modify the built form of these 3 locations, try to increase the FSI as per the maximum permissible FSI based on the 2019 building regulation. Then in case 3, the 2019 regulation was further modified. We did not, we achieved the FSI. However, in the setbacks, the case 2, the setback vegetation cover were kept constant. In the case 3, we tried to replace that. In the setback, 50% of the building setback was considered as vegetation with trees, and planting at an interval of 6 meter to 9 meter. So this is just done to analyze how the development regulation, whether it is improving the comfort condition at the lower level, at the street level, and what combinations of urban form can help in mitigating this UHI, if applied at a city scale, can have a larger impact, which can improve the comfort condition, especially for people who are staying in the outdoors, because most of these vendors and poor stay throughout the day, and they spend their time outdoors. So that's basically so based on those classification, as per 2013 regulation, these zones were open mid-rise, compact low-rise, and open low-rise. When we modified this with regards to case 2, wherein the scenario was changed to um, the 2019 building regulation, the open mid-rise remained the same, because we couldn't do as such. There were a lot of green spaces there. But then the compact low-rise, when the FSI was increased, it became compact mid-rise, and the open low-rise again was changed into open mid-rise because of the impact of the 2019 regulation. Further, when we added the vegetation, though the classification of the built form did not change, but it had a significant impact, because of the green cover and the trees reduced the thermal stress throughout the day. Especially it reduced the thermal stress from 7 hours to 4 hours. So this is basically based on the comfort condition. So the study also highlighted the significance of deeper asymmetrical canyons with higher accessibility to direct sunlight, that increased mean radiant temperature, which is the comfort parameter. However, the trees at the street level, because of the tree cover, it reduced the it improved the comfort, and it reduced the solar radiation. But at the higher level, we can see, I think this is basically how the air temperature and the comfort condition varied in the 3 scenarios, out of which the third scenario, wherein we had 50% permeable surface fraction, which allowed, because the concrete jungle absorbed a lot of heat, the permeable surface did not absorb heat, because of which there are a lot of the comfort indices would improve, and it also improved the entire microclimate of the neighborhood. So here, the built form parameters such as density, orientation, again, it also helped in opening up the upper level where the sky view is more, so that it can radiate all the absorbed radiation back into the atmosphere. So the parameters that the built form, which have a significant impact on urban heat island includes the building heights, aspect ratio, vegetation percentage, and these have to be done based on these local climate zone approach, which can give us a significant result and how these can impact the comfort condition, how these can improve the comfort condition, because these may not be the same in different city for all the cities, so it has to be contextualized. And when taking into a coastal city, the streets again, we have to enhance the wind movement with the orientation of the streets, and the street need to allow the wind to pass through, so that that will give some kind of relief to the occupants, because the air movement can enhance comfort in high humidities and high temperature cities. So as such, that will create lot. So the orientation again in terms of planning becomes important. So these basically are some of the results, wherein the sky view factor, as it increases, the thermal comfort conditions also increases. So it is we'll have to arrive at an optimum range. So the range of 0.3 to around 0.5 is said to provide optimum comfort rather than achieving one or very low. So it is always better in a hot and humid city to go in a range between 0.3 to 0.5, which performs much better when compared to a higher sky view factor. So that would improve the, it also improves the other comfort index like mean radiant temperature, which is a combination of wind velocity, solar radiation, air temperature, and humidity. So here again we could see that there is a significant reduction. This 0.3 to 0.5 works better when compared to higher sky view factor. So these again, so here the recommendation basically optimum sky view factor is important. So 0.2 to 0.3 basically reduces direct radiation into street canyons, but however it will also reduce the re-radiation during night time. So that needs to be taken care. Taller constructions with low building surface fraction are better to mitigate urban heat island. Then plot coverage 50% to 60% for medium rise and medium dense are better. And also stilt or basement covered parking facilities better, which enhances air movement at the street level, which can provide additional comfort to the occupants at the street level. Creation of smaller playgrounds are better instead of creating huge open spaces, because these open spaces again, smaller playgrounds have a greater impact on the microclimate when compared to large open spaces. uh, Also, the permeable surface again does not retain the solar radiation during daytime, so which can minimize the heat island during night. So this LCZ approach, local climate zone approach, have been found, and this can help in designing appropriate urban design guideline, which can improve the outdoor thermal comfort. But the challenges that have to be addressed is these cities have to be classified. Basically, the local climate zone classification is very significant. All these cities have to be classified. Then analysis of interlocal climate zone temperature variation also need to be analyzed. But then to analyze all these, we have challenges like how do we analyze unless we have concrete in situ field measurements to support or validate. And these can be compared only if simultaneous measurements can be done. And we also have require a lot of reference meteorological station to compare how these temperatures vary at different urban morphologies. And of course there are simulations that could be done, which will have its own restrictions. And this in order to assess the future scenarios, that is also there, because the regulations keep changing and it keeps varying at different time. So assessing them accurately and then trying to identify how it would how the outdoor thermal comfort would be there in future. And then basically conversion of setbacks at the plot level is as per the individual's decisions. That is again difficult. Along with all these, we also need to consider that pollution and anthropogenic heat, which will again add on to the discomfort. Thank you.
Thank you very much. Dr. Lily Rose, just one small question for clarification I had.
Yes.
In your last slide, you showed that in a neighborhood, it
Yes.
is better to have smaller playgrounds rather than large open spaces. Could you
Yes.
just clarify that in a minute?
Yes. See, basically, when we take large open space, it will have an impact only in the immediate neighborhood of the large open space. When you have streets, the building that just abutting the neighborhood, the microclimate varies. But then the streets that are in the secondary streets, which are little far away, the impact is very less. So we did some experiment with varying fragmented open space and large open space.
Okay.
Found that the overall microclimate reduced significantly when we have smaller open spaces, smaller parks when compared to large green parks.
Okay. Thank you. Kirti bhai.
A small little thing, Dr. Lily, thank you very much. But what I wanted to ask you is this, that can we take Chennai's given building bylaws,
Hmm.
work on them, and
Hmm.
say these are the 10 things that needs to change?
Yes, we
So
can.
then, because then what happens is that you're using your skills, your knowledge, your understanding, you're taking it to people, you're taking it to the street, you're taking it to the construction program. And we will be very willing to work with you if that is what is to be done.
Definitely, definitely. I would be interested.
Thank you. Thank you so very much. Uh, we'll take, of course, more questions later. This is something that just struck me and Kirti bhai immediately. So thank you very much again, Dr. Lily Rose. We'll certainly get back to you later. I'll next call upon Dr. Pradheeps Muthulingam, who's with the UMC in Chennai, and he has been part of the Climate Change Advisory Committee to the Chennai Metropolitan Development Area, a person with clearly very good insights into the issues involved in Chennai. So without further ado, Dr. Muthulingam, please.
Thank you, sir. Lily ji, can you stop sharing the screen? Thank you. Okay. Yeah. Next slide. Yeah. Thank you. Thank you, INHAF team and Kritisha, sir. Thank you very much. I'm very happy to be present among the experts to discuss about urban heat island effects in Chennai. So as we discussed, as Kritisha sir has mentioned that I am going to keep my presentation on these five broader themes. One is on resilience and what are the main actions required to reduce urban heat island, which my counterparts Lily ma'am and Raghunandan, Jayanarayanan had discussed. Then cities framework policies at state and national level, and Indian cities policies, finance, and capacity support. What is the current scenario in India? And finally, the fourth and fifth as national, whether we need a urban heat action plan, and are we going to look at a new policy measure at national level? So that is my discussion points. Next slide, please. So briefly, before going into deeper, I want to show how the Chennai metropolitan area has been transformed over the years. So here you can see on the left side is the first master plan's Chennai metropolitan area, which is very, very minimal, 125 odd square kilometers. And following that, you have the water bodies like Kuvam River and Adayar River, which are on the boundaries. And it has progressed over the years, and the second master plan had come down to the second master plan, And on the right side, you can see the first master plan's total geographical area. So the first master plan was focusing on more on creating road connectivity and densification of population, and how the government was looking at finding or identifying new areas to settle the incoming population to the city. And please, next slide, please. Yeah, so here on the left side is the second master plan land use. So you can see a lot of colors, which are the zones prepared and developed by the Chennai Metropolitan Development Authority. So it was earlier Madras Metropolitan Authority, has been renamed to Chennai Metropolitan Development Authority, and currently it is on action till 2026. And Chennai Metropolitan Development Authority is involved in the preparation of the third master plan for the Chennai city. On the right side, the left side is the second master plan area, that is 1,189 square kilometers. So when we talk about Chennai as a city, it restricts itself to the 426 square kilometers, which you can see on the white block in the left side map. And the beyond areas are called as Chennai metropolitan area. So the entire area, we call it as Chennai metropolitan area. And currently it has been expanded from 1,189 square kilometers to 5,904 square kilometer. So that is what represented on the right side. You can see that. So when we look at the urban hinterland expressed by the earlier speakers, so you can see the road networks and along the borders. So inner Chennai area, then Chennai metropolitan area, and finally you can see that. So those hotspots which we have seen in the earlier presentations were very true, which are the newly developing areas and industrial areas, and the population is very increasing very much, and the Chennai's urban sprawl is because of that. So there is a huge connection between Chennai's urban population and then the urban development and urban hinterland. Next slide, please. So here, the green cover, the map prepared by one of the non-governmental organization, Carrier Trust in Chennai. So that it shows the difference between the green cover that existed 2 decades back and the current green cover scenario here. So you can see a drastic decline in the green cover, which itself, alarming for ourselves to look at how we are caring about the environment and how the plan and development is happening in Chennai. Next slide, please. Yeah, here you can see the water bodies, the waterscape. The river basin map is on the left side, which is Chennai River Basin, which almost has its upstream area beyond the Chennai metropolitan area. That is even the newly expanded area, 5,904 square kilometer. So the entire river basin, the entire Chennai city is within the river basin. It got 4 river basins, that is 3 river basin and 1 coastal like wetland-based basin. So we have Kosasthalaiyar on the northern region, and then Kuvam River in the middle, and southern part is the Adyar River. And the wetland-based river basin, we call them as a river basin, is Kovalam Basin, that is on the right side corner in the left side map from the Pallikaranai, and it goes along with the Buckingham Canal and reaches the Kovalam and flows into Bay of Bengal. On the right side, it's actually a GIF image how the urbanization caused encroachment on water bodies over the years starting from 97. Okay, so since this is a PDF, it cannot project, and I will move to the next slide. Can you please? Next slide. Yeah. So as I don't want to go deeper into the definition and all, urban hinterland, as we have accumulation phenomenon, which is highly expressed in the urban area due to construction and human activities. It is most evident characteristic of urban climate, how the climate change is impacting humans, environment, and the entire nature. Next slide, please. So as I come to the first point of discussion, what are the main actions required to reduce urban heat island effect? So you can see what is exactly is required. We need urban heat island mapping. We don't know anything about urban heat island so far. We were talking about or discussing about heat waves across the different states in India and as well as across the global level. So heat island mapping is very much essential. As Professor Lilly said, we don't have any local climate zones as per se, because whatever the climatic zones which is at present in place is agroclimatic zone, which has been framed almost 3 or 4 decades back. So that is not at all a point of consideration at present. But what we do is still rely on the agroclimatic zones, and we don't have any local climate zones. But the local climate zones should represent how the urban characteristics, urban mosaic had developed over the years based on the low-rise buildings, mid-rise buildings, high-rise buildings, or combination of both commercial buildings along with this. So we need to have a urban island mapping. So that is should be a first hand objective of a heat action plan for a city. So the third master plan is focusing on preparing such a mapping which will include the data of past 20 years, that is 2 decades, and it will project into the next 2 to 3 decades, or say 2046 or 2056. And also it will also, they are projected to the end of the century, how the population is going to be increasing, and how this urban heat island will behave with the dependence of population inclination in Chennai metropolitan area. Then the next is we need urban heat resiliency action plan. Since action plans which we talk is more oriented towards immediate response and resilience among the communities. But the heat resilience action plan should be a part of the master plan, so that it will come along with various focus on how the development should be in the future and how the population distribution should be in the future for a city. And the third is much essential, as Professor Jayanarayanan had mentioned, the nature-based solution, that is blue-green infrastructure plan. So Chennai Metropolitan Development Authority already started to work on estimating and auditing the blue-green infrastructure capacity of the city for the entire 1189 square kilometers. So that blue-green infrastructure plan will provide the entire cities green cover, and also the water bodies and other river structure within the city. So with this as a base map, we put together how the zoning should be done, how the master plan should be established. It will give a proper resilient master plan for the city. That is what Chennai Metropolitan Development Authority is currently looking at to develop. And fourth is very important, as Kritisha ji has mentioned, the building bylaws and regulation. So when we consider urban heat island, what are the reasons, what are the causes? It has been detailedly explained by Professor Lilly, how the materials, building designs, height of the buildings, everything is creating a thermal discomfort for the communities and also for the land. So that is what we have to look at, how we are going to change the building bylaws that can accommodate this urban heat island effect, and reducing the mitigation action plans as well. The regulations in this speech is the Tamil Nadu Combined Development Building Regulation Rules. So it is has been reviewed by Chennai Metropolitan Authority with all these climate resilient oriented actions within the building regulations. So at present, Chennai Metropolitan Development Authority is working on that, and we hope this regulations and bylaws will be included in the master plan as a policy tool to bring out the proper urban heat island mitigation strategy. And then we are at a stage where we are looking at the impact of urban heat island, and also we discuss about thermal inequality. So we need to have a heat equity plan. We have to include this low income groups and vulnerable communities, which are going to be very much affected because of urban heat island and the climate change. So local heat equity plan at a zonal level for the Chennai city, or at a district disaster management plan kind of a thing should be established. This kind of a concept is very much new for us, and this should be in place, that the master plan should also includes a local heat equity plan, so that it will bring up the financial strategy to implement the required mitigation and adaptation strategies for mitigating urban heat island. And finally, for infrastructure, we have the ECBC thing is already present in Tamil Nadu. Tamil Nadu is going to be implementing the ECBC at a state level wide. And we also have to mandate the B star rating or Grihas rating, how we look at the quality of materials which is used for construction, which can reduce the pollution, reduce the energy efficiency, and also, reduce the energy consumption and reduce the carbon emission. So which in turn have a serious effect on reducing the urban heat island effects. And finally, the mindset and culture of adapting to a new phenomenon should be in place. So we have seen it ourselves during the COVID pandemic, how we have started to learn ourselves to be clean and hygiene. So that kind of a cultural change should also be there for climate change adaptation and also urban heat island per se. So increase of land surface temperature, which again, it going to be affect at a drastic level in urban climates, urban hydrologic situations, soil properties, atmospheric environment, biological habits, material cycles, energy metabolism, and residents' health. This is a encompass of the entire city's metabolism. So the city should focus on having an urban heat island plan, and that should be an important major action for this. Next slide, please. So the second discussion agenda is the city's framework. What are the existing framework policies that are there, which can be linked with urban heat island effect, and how we can look at. As I said earlier, local climate zones should be in place. The government should establish a clear local climate zone, and city master plans, like how the third master plan is prepared by CMDA. We should have a city level master plan that should talk about this climate change and the risks and vulnerability of the climate risks. Year 2019, like the building regulations and city climate action plan. And the important focus which at present Metropolitan Development Authority as well Department of Environment and Forest in Tamil Nadu is looking at is adapting the urban cooling program, which has brought by United Nations Environment Program. So there is an MOU already between the Tamil Nadu state government and United Nations Environment Program. They are working on the urban cooling program, and which again established by National Institute of Urban Affairs along with CEPT University. They are combinedly developing this urban cooling program and guidelines for that, which can be adapted by other cities, whether it is on a hill station or whether it is on a desert, wherever it is, the urban cooling program and the guidelines will provide clear-cut roadmap to adaptation for urban heat island. And the district disaster management plan, as I said, is a framework which will be very much useful in reducing the anthropogenic heat emission. And we have the Amrut, the smart cities plan, which helps us improving the urban surface, urban development, the characteristics. So this should be looked at as an important tool where the urban heat island can also be included in that while preparing a smart city plan. And we have in Tamil Nadu, in Chennai, we have in the Green India Mission, which talks about implementing, increasing the forest cover at the state level. So that also can also be included in that. And Tamil Nadu Wetland Mission is there, rainwater harvesting, sustainable development goals, and nature-based solutions are other policies which can be looked at both state and national level. Next slide, please. For Indian cities, the policy, finance, and capacity support, which I discussed, is about the nationally determined contributions. So we are looking at reducing the emissions, net zero target by 2070, and we are looking at improving the renewable energy resources for energy for our country. So we have other ministries which have the possibilities and the policies like national environment policies, Green India Mission, environment impact assessment, which can help in including the urban heat island related plans in the we have sustainable habitat and smart cities and other barrier-free built environment for disabled and elderly persons, which can also act as a policy option where taken a important route to include it in the city level master planning. Then the carbon credit trading scheme. So this I wanted to highlight here because we are looking at financing for urban heat island adaptation. And so we have the different schemes are there. So currently the green municipal bonds developed based on the carbon credit trading scheme. Indore has got 7.2 billion Indian rupees, and the green bonds framework itself accounts for 3 billion for the financial year 23 and 24. Likewise, we have the other programs which are possibly a greater step for including the urban heat island as a important tool for reducing urban heat island effect and also addressing climate change issues at state level and national level. Next slide, please. So this is about the blended financing mechanism, which has been come into force, that how we can include private mobilization, finance mobilization, how we can use the corporate social responsibility funds, how the India's pure financial facility can help in bringing up the renewable energy, increasing the renewable energy, etc. Next slide. So finally, for the National Urban Heat Action Plan and new policy measure at national level, yes, we are at a situation we need to have a national level new policy for urban heat action plan and also for climate change. So the model building bylaw, which is already in place, should include that. And as I earlier said, national NBCs and ECBC RICA rating should also be part of it. And other energy efficiency measures like urban cooling program should be in place. And the construction designs and guidelines should be changed, which will include in heightening the platform or the housings and buildings, and also how we bring this change by including as a capacity building training as a major tool for creating a cultural difference among the engineers, builders, and the officials of the city level master planning and implementation authority. As transportation, where we have to look at as an important option to mitigate urban heat island effect is by reducing the pollution. So implementation of non-motorized transport can be an important tool, and equitable road space, cleaner transport fuel technologies, and also protecting the sensitive areas such as forests, urban green cover, and water bodies. So this, I would like to thank you, and I'll stop my presentation. Thank you very much. Thank you for your patience.
Thank you so much. Excellent presentation, Dr. Muthulingam. And I am particularly grateful for you for throwing light on the efforts being taken by CMDA, particularly towards the implementation, hopefully, of the measures in the Chennai Climate Action Plan going forward. Because one of the things we have always noted, of course, in India is that there's a fair gap between plans that are made and then where they are implemented. So hoping that the implementation follows closely on the plan, I think they can be the recommendations you've made, the suggestions you have offered will really go a long way to mitigating the issue. Thank you so much, Dr. Muthulingam. I'll next call upon Souvanic Roy from what used to be called the Shibpur Engineering College famously, and now the IIEST, where he is the founder of the Climate Change Center there. Professor Souvanic, over to you.
Yeah. Good evening, and thank you, Dr. Raghunandan and Kirtiji for INHAF for giving me the opportunity to share my experiences on the climate change work, what we are doing at our School of Ecology and Human Settlement. And I'm also thankful to the earlier presenters who have made a very insightful presentations to actually explain in great detail about the Chennai situation, and also the various initiatives and how they could be incorporated with the heat island issues and heat action plan. So can I share my screen now?
Yes, sir.
Okay. Yeah. Yeah. Is the screen visible?
Yes, sir.
Okay. So yeah, this topic of my presentation is aligning my by my observations on the broadly on two levels. One is the heat stress scenario at the larger national level. And then I'll be briefly talking about our work on Kolkata and what are the takeaways from that. So coming to the issue of this heat stress scenario, as we all know that this is becoming a major challenge in all regions of the world, not only the presently urbanizing part of Asia, Latin America, and Africa, but also in the so-called cooler or temperate zones of North American cities and Canadian cities and Europe also. So, and there is also a prediction on from IIPC that this is likely to increase, and this is going to create a huge impact on the cities, because cities are the places where there is concentration of the global warming emissions, and due to that the concentration of heat island. So coming to the some of the basic observations, that heat waves are actually considered or thought about the silent killers in cities, because unlike the floods and cyclones, which instantly damages and kills a lot of create problem instantly, this is a silent killer in a sense that it is actually reducing creating a long-term absenteeism in the work and loss of man hour because of its prolonged exposure in cities. And what we see is that though the number of heat-related deaths are not very high compared to some other natural disasters like earthquake and others, but it has a prolonged impact on the psychological and social conditions, and also this is more impactful for the lower income group or the informal workers. And the Global Center on Adaptation, they have actually predicted that there will be a rise of temperature from 1.5 to 3 degrees centigrade by 2050 compared to the 1981 and 2010 scenario. And if we look into the Ministry of Earth Science heatwave days, which was very high in 2022, but which is slightly ups and downs. In 2022, there are 2003 number of heatwave days in which was spread in different seasons, means in different months, which is significantly high. Coming to some of the works which have been done by WRI, which shows that they have made a very interesting study in the year of 2022 for 3.5 months, and where we see that almost 70% of urban India is exposed to high temperature. And in that, what we have seen that 40 to 60% of the population, that is from 60 crore to about 90 crore population, were exposed to 38 degree to 42 degree of temperature. So that's the kind of scenario what we are in. And in 2023, there was a huge disaster happened in Navi Mumbai, where there is a public event. 13 people lost their lives because of the kind of exposure to heat in that situation. And mostly the northern part of India, the part of the southern western coast, and also the central and eastern India are exposed to this. And what we see is that those people which lack the affordability, and also their income level is low, the urban informal settlements, street vendors, daily wage laborers, they are mostly the people at risk. And what we see is this happens due to the increasing vehicular emission, the larger usage of air conditioners, loss of natural vegetation. These are actually accelerating the creation of heat islands, and this is leading to the heat stress and heat index. So again, I come back to another IPCC report, which is the 6th assessment report. In fact, this report has talked in detail about these heat stress scenarios, and this shows the situation of Calcutta, which shows that the Calcutta is warming at the highest rate among all the major cities in the world. That is, it shows that in last 7 decades, the Calcutta has heated up to plus 2.6 degree, followed closely by Tehran and far away the other cities in the world. And out of this heating, that more than 80% of the temperature rise in Calcutta is contributed by urbanization, which is a matter of great concern. So also this IPCC 6th assessment report, they have dealt in detail the heat stress factors. And what we see here, the 5 factors there are 5 factors which are contributing to the heat island or warming scenario. First is the city geometry, which includes the layout of the city, height, and the building density. The LCZ is what Mrs. Lily Rose has mentioned, is actually that is part of the city form and city geometry. So that is contributing to the positive side of the heat stress. The second is because in cities, what we see now, because of the rising heat, there are more number of air conditioners and these gadgets, which are actually which we call as the anthropogenic heat, that is also rising. And the third one is the heat trapping property of the buildings and road materials. That is basically the low albedo material, which cannot reflect the heat very immediately, but it retains the heat and it releases the heat in the night. So that is the kind of heat trapping potential of various materials, and also because of the high thermal mass buildings and the typologies. These are contributing significantly to the heat island creation of the heat island situation. On the other hand, there are 2 natural features which we consider as the blue-green infrastructure, that is the water, natural lakes or water bodies, canals. These affect the cooling of the city, and also the vegetation, which this is also the canopy cover and the green areas in a city, which also plays their role in the cooling of this city. So finally, what happens is actually a composite effect of these 5 factors skew the balance either on the positive side of the heat island or towards the cooling effect. So that is what should be the assessment or the analysis angle which should be initiated. Now, coming to the Calcutta scenario, this is very interesting that Calcutta, you all know that this lies in the warm, humid climate zone, and it is a low-lying deltaic city. Means the Calcutta was actually a city of wetlands, and actually the whole city has grown by reclaiming the wetlands on the eastern side of the Calcutta, which is a Ramsar wetland site. And we have done urban heat island mapping 7 years back. In fact, that situation has further aggravated now. And where we have located this LST values, here what we see is that the red colors are the highest surface temperature varies from 37 to 40 degrees centigrade. And what we see here, there are few discrete pockets, but they are mostly concentrated in the old city of North Calcutta, where the new high rises are coming. Also on the western part of Calcutta, where it's already very dense, and there is a large scale transformation which is happening. And also the third one is on the eastern side, where there is a wetland. But if you see the city growth, that these wetlands are actually where there is a large scale transformation happening through real estate driven urban growth. So in fact, the Calcutta's urban economy is now entirely driven by the real estate. So that's the kind of scenario. And under this situation, what we have seen, that there's a large scale shrinking of the green spaces. In just last one decade, it shrunk from 13% to 5.5%, which is actually numbers. If you see that from 8,000 water bodies in Calcutta, it has drastically come down to around 3,000 or 3,500. And the per capita green space, if you see, that is abysmally low in Calcutta, which is less than 1 square meter per person, which is according to WHO norms and also the URDPFI norms in a healthy city, which should be around 9 square meter or more. And this is the green space thing. And the water bodies also, what we have seen, what I told, that the water bodies have reduced from 8,000 to in last one decade to 3,000. So it is more than 50% has been reduced. So these are the two reasons why the urban heat island in Calcutta has been rising because of indiscriminate real estate transformation. And what we see is this is the kind of present scenario of urban development, or the building typologies or the type of urban form. On the left-hand side, what we see is the picture where you can see that in the foreground there are these wetlands, and just these wetlands are getting encroached and taking encroached upon, and you see that very high value real estate which is coming up on the eastern, along the eastern bypass. And this is the kind of situation where the new heat islands are emerging at that place. Similarly, we see the large scale use of structural glazing and curtain walls, irrespective of the direction. This kind of curtain walls are also radiating a lot of heat on the street level, and also absorbing heat and increasing the cooling load. And finally, it is leading towards more usage of AC and creation of anthropogenic heat. Wherever, if we compare to that, if we consider comparatively the traditional city fabric in Calcutta, which was both in the North Calcutta and also part of Southern Calcutta, which was a very different form, which is more like a form which is high density, low rise, which is basically a very passive cooling type of urban form morphology, which was there. The buildings having, though they have a higher footprint, but they have a courtyard, and also they have larger windows, but not, the windows are not actually glazed, but with timber windows with smaller area of glazing, and also a lot of wooden louvers which are used to allow the to block the heat and but allow natural ventilation. So those kind of fabric was prevalent until 1990s. But after globalization, in fact, there is, and also the nuclear families, all these buildings are now giving away over to the real estate, and which are taken over by large scale high-rise buildings, which are actually taking over by a very different kind of urban form, which is not thermally very comfortable or they actually flout the rules of this passive cooling. So coming to the conclusions, we say that what actions are required for this type of city, which is actually in a warm, humid zone, and which has a lot of water bodies and wetlands. So we have to take the lessons from the traditional habitat and building practices in the city, which developed on passive cooling urban form, the building typologies with the courtyards and more of larger size of openings, less use of glass. So material usage is very important. More of masonry materials and less of glass materials, and resource conservation, like the old open spaces, the water bodies were highly preserved in that. So probably that is one thing which is very much required for both for retrofitting in the older areas wherever there is possible, and also for the newly upcoming neighborhoods. These principles are very useful clues for future development guidelines. Second one, the takeaway would be that amendment of the city building bylaws and the zoning regulations, and also the national codes. Now we have the ECBC and also the Econivas Samhita, and we have done research on that how this Econivas Samhita could be further amended or refined, and the ECBC could also be further amended to actually look in incorporate the urban comfort parameters, and also the parameters which are useful for smaller size of buildings, because this smaller size of buildings still actually dominate the situation, with 70% follow in that category. So there is a lot of possibility of refinement and amendment in the improving the thermal comfort performance and energy performance of these group of buildings through zoning regulations and the codes. Third one is what is very much lacking in Calcutta is there is hardly any risk awareness and also vulnerability mapping of the heat stress, the distribution of the heat stress and who are actually affected most. So we need to create a collaborative learning platform and participation among various vulnerable sections, and also interacting with the other stakeholders, so that we can have a risk awareness among the people. And who are the most vulnerable sections? Obviously, the people, the street vendors, their business is mostly affected. So this has to be brought into the analysis and the knowledge sharing platform, and accordingly the vulnerability mapping has to be done. And finally, there is a need to restructure the state action plan for climate change, and also the climate action plan, the city action plan for climate change. Like Calcutta has a action plan for climate change, which has not included the heat action plan or heat island issues or heat stress issues. So there's a need to incorporate this heat aspect, because most of the climate action plans are have talked more about the storm surges, flooding, and this cyclone issues, but hardly talk about the heat stress issues. But in last 1 decade, what we saw that this is becoming a major problem and challenge, and this should be looked into through this state level action plans and the city level action plans. And this should be, the heat action plans should incorporate the UHI mitigation measures through alternative habitat strategies, like passive methods of techniques of the built form or the urban form, like high density, low rise buildings. Then the West is a major contributor to the GHG emission, because there's a high rate of urbanization in West Bengal, and also in the peripheries of Calcutta, where waste is not at all treated, and that is a major contributor to the methane emission. So there is a need to, apart from the buildings, need to look into the waste management strategies, how this could be scientifically managed, or this could be recycled so that its further amount could be reduced. And last but not the least is whatever is remaining in terms of the blue and green infrastructure, like the wetlands, water bodies, and also the revival of the old water bodies are very important to address this critical situation in Calcutta. Thank you.
Thank you very much, Souvanic, for excellent presentation. I particularly like the contrast and the comparisons between the situations in Calcutta and in Chennai. I find a lot of parallels. I find it also interesting that both the Chennai Climate Action Plan as well as the Calcutta Climate Action Plan, while talking about urban heat, have not devoted a separate section to the urban heat issue as a major issue. And I think it is good if we together, as people who are interested in urban practice as well as people interested in the climate issue, really highlight the urban heat issue as a major construct to be integrated into our climate action plan as well as our urban plans as well. Thank you very much once again. I'll now invite our last presenter of the day, Karthik from the Climate Chennai project, and he will be presenting the findings and suggestions that we have arrived at after our studies in Chennai. Karthik, please, over to you.
Thank you, Raghuji. Yeah. So I'll just start with just briefly telling you about our approach over to climate action in Chennai. We started this a couple of months ago, and I just wanted to, like, at the outset, just clarify that this is not meant to be a criticism of the Chennai Climate Action Plan, but rather it attempts to add value to it. And our focus, or rather our approach towards this has been to emphasize on actions with co-benefits between sector and across adaptation and mitigation. Now, the approach paper consists of 7 chapters, which also make up for the subjects of our webinars. And today we're talking about urban heat island. Now, I won't, so Chennai is one of the oldest municipalities in India and is the 4th largest metropolis as well. 30% of its settlement lives in informal, 30% of its population lives in informal settlements, and it has a large working population as well. Now, all this is important because Chennai, incidentally, happens to be the 7th most vulnerable district to climate change, which makes it a priority for not just the state, but for like climate action in general. Now, I won't get into what UHI is and to define it, because I think distinguished panelists have done it way better than I could ever hope to. So I'll just get into how UHI is affecting Chennai and what we what our findings have been. So we've noted that temperatures in the city are often 2.5 degrees Celsius higher than rural or surrounding parts of the city. And some parts of the city, this difference is as high as 4 degrees. Also, the current average temperature, the wet bulb temperature of Chennai is 32 degrees Celsius. And as you may have already heard, that a temperature of 35 degrees Celsius, wet bulb temperature that is considered to be the limit of human survivability. So if this temperature was to increase just by a few degrees, which is expected to happen since climate change is going to lead to more frequent and severe heat waves, we will, very soon be crossing this limit of human survivability. I think this really points out just how important and crucial this entire subject is. Now, outdoor workers and people living in low-income settlements are the most vulnerable to urban heat island effect as well, for pretty obvious reasons of high density settlements and the nature of their work, which makes them, vulnerable to urban heat more than people who work indoors. Now, contributing factors that we have, wanted to highlight was that the green cover of Chennai has declined sharply over the last few decades. It has basically reduced, and as the built up area has expanded, as it happens for most cities. Chennai, unfortunately, has one of the lowest percentage of green covers in all metropolitan cities across India, with just 5 to 6% of its area by like by land being under green cover. Also, Chennai currently has about 8.75 square meters per person of green space, where the required norm according to WHO is 9.5 minimum. So we are well below what the requirements are. And even for green cover, the requirements for a city are supposed to be around 30%, but we're just at 5 to 6%. Chennai used to be called the city of 1,000 tanks. Tanks as in like water bodies, but unfortunately this is no longer the case because most of the water bodies have simply vanished, for well, real estate basically. And from 60 large water bodies, the city is now down to just 28. And the area under water bodies has reduced from 12.6 square kilometers from about 100 years ago to just 3.2 square kilometers as of 2017. And this is also a major contributor to UHI, and it's also pretty poorly distributed across the city. And the third and final contributor that we'll be highlighting today, which we feel is a very important contribution to UHI, which is often overlooked, is the rampant use of air conditioners. Now, air conditioners are one of the fastest growing consumer electronics in India. And they are growing at a rate of almost like the demand is growing at a rate of almost 10% per annum. But despite that, the penetration of energy efficient air conditioners is pretty low. This is usually down to the fact that they cost a bit more than your less energy efficient air conditioners. And air conditioners can contribute to as much as 1.5 degrees Celsius to the urban heat island effect. And also, according to the Chennai Climate Action Plan itself, 60% of Chennai's electricity demand comes from cooling alone, so which has a massive effect. There's also a phenomena that basically we need to understand that people use air conditioners because of higher UHI, right? But as the use of air conditioners increases and gets more widespread, that contributes to a higher, heat island effect, which feeds into the higher demand for AC. So it becomes basically a vicious cycle, which just keeps increasing and increasing endlessly. There's also poor usage practices of air conditioners, and also not lapses, but poor building designs and materials, as Dr. Lily was speaking about. Finally, what potential responses do we see for helping with urban heat island effect? Well, our first two suggested responses are to increase the green spaces by a major expansion of green areas in terms of local parks, city forests, trees along streets, and riverside development, and so on. We envisage that the city should target for at least 25% of green cover. And this also needs to be part of the master plan, which I'll explain in more detail in the coming slides. Also, we want to emphasize on the need for shaded trees, shade line streets and walkways, and also shaded rest areas, along with distributed drinking water stations and staggered timings for construction sites. Now, apart from having the direct benefit of helping with the UHI, these will also have the co-benefit of like a tree cover of 25 to 30%, according to our estimates, will sequester about 10% of the city's carbon dioxide emissions, which is going to help it greatly in its net zero targets. This also plays towards the climate justice angle of climate action, as reducing the UHI will benefit workers like outdoor workers and low income settlements the most. This will also reduce healthcare costs and reduce morbidity and mortalities in the city. Green cover will also improve the well-being of the city along with the overall livability of the city, while also adding to the biodiversity of the city. Now, second suggested response is the conservation and restoration of water bodies. Now, water bodies have, of course, a direct benefit of cooling over substantial distances, especially during the daytime. But in Chennai particularly, these will also help with flood control, which is a major problem in Chennai, as like Chennai experiences floods pretty much every year during the winters. And conservation of water bodies will also help with wellness, just like green cover, of carbon sequestration and increasing biodiversity. And if we ensure that these water bodies are distributed well, this can also have impacts on the equity angle of all of this. By if we ensure that low income areas also get water bodies, appropriate water bodies, it should help us with equity as well. And now the final suggested response is focused on energy efficient ACs and energy efficient practices. Now, this has a potential of reducing UHI by at least 1.5 degree Celsius. We need strong and urgent mandates or incentives for energy efficient ACs. And we also need information campaigns or awareness campaigns or even commercial mandates for temperature settings, which temperature settings to just 25 degrees Celsius, which have proven to have which have had proven like to have big benefits in China, Japan, and Korea. This basically plays into for having appropriate practices to reduce power use and heat emissions. Now, this will also have the co-benefit of reducing the energy demand of the city by as much as 25%, while also helping individuals reduce their energy costs. So it's a win-win for both users and utilities and AC manufacturers. And we also envisage that using energy efficient ACs will help in reducing emissions by at least 10%. And most importantly, this intervention would target the better off more, like people who are able to afford air conditioners, and basically helps with the equity of climate action. Now, to conclude, so UHI in Chennai as major contributing factors are green cover and reduction in water bodies and use of air conditioners. And solutions are pretty straightforward: by increasing green cover, restoring and conserving water bodies, and implementing energy efficient ACs and practices. Now, I also just want to state that the master plan here does play a very important role, especially when talking about green cover and conserving water bodies, because since master plan is the only statutory document of any city, these policies do require to be integrated in the master plan if we are to have any chance of having it implement properly. So yeah, that's it from me. Thank you. Raghu, you're on mute.
Yeah, so thank you very much, Karthik, for your very compact and quick presentation. I'm grateful to that because we are running close to 8 o'clock, which is our closing time. There's not too much time left for discussions, but we can certainly take a few questions that have come. Let me first place, there are two questions which have come in the chat box itself. So I'll place those, and the two questions that I can see which have come are, one question is about can any of the speakers throw a little more light on how remote sensing can or is being used to understand the different aspects of the urban heat island effect. In fact, I think Dr. Lily Rose's presentation had several aspects which he had got from remote sensing activities, as well as some of the others. Maybe Dr. Lily Rose would like to quickly respond to that.
Yeah. Basically, if it is using remote sensing, it focuses mostly on land surface temperature. So the satellite images that has the surface temperature characteristics, only that can be used wherein if you want to do air temperature studies, then it has to be through other means of field measurements or simulation. So the land surface temperature is, there are few recent studies which are trying to convert the land surface temperature to air temperature at present, but it is they're not been completely foolproof. Still, it is in the process of doing it. Right now, satellite images are used only for the land surface temperature studies.
Yeah. The only thing, of course, is you can add also that remote sensing is also helps to prepare
Yes.
the green
See,
areas maps, the water
not
bodies mapping. So putting all those together, you can draw a picture which will help in.
especially remote sensing would give us an idea of city level urban heat island.
That's right. That's right. That's right. The other question which came up, which I thought was interesting, is one questioner has asked that there are cities which are also undergoing the urban cooling effect. And is that a problem that we should be taking as seriously as we take the urban heat island? Will you take that, Dr. Lily?
Yes, definitely. So cool island is basically identified only during daytime, especially in dense urban fabric. So that is beneficial if it is in a hot climate, like hot and humid climate like Chennai. But when it comes to cold climate, then urban cool island would have a negative impact. But these urban cool island during daytime, it may create lot of heat islands during night. So these cool islands, again, we'll have to see daytime UHI and nighttime UHI, compare that, and then we have to optimize that. Urban cool island are beneficial for hot climates, basically.
Yeah. And also, I think the urban cool effect, if you can call it that, are noticeable in pockets within cities
Yes.
rather than perhaps applicable to the city as a whole.
Yeah.
So you will find cool pockets in the city next to parks and next to big city forests, areas
Yes.
like that.
Right.
Plus,
No, the urban cool islands, yes, definitely in terms of parks and things, but there are also, if you see in dense urban fabric, during daytime the temperatures can be below as low as 2 degrees when compared to the other urban areas. So
right.
because of the shade, but then those areas would experience very high temperature during night time
Yeah.
because of absorption.
Correct. Exactly.
Actually, in Chennai, during the urban heat island effect ongoing study, we observed that several highways, which earlier has expressed urban heat island, because of the elevated metro railways, there is a shade and had reduced that heat island effect. So
Yeah.
Yeah, daytime they're definitely beneficial in hot climates because these metro lines have reduced the temperatures at the microclimate. But then during night, these concrete structures which is absorbed started heating, and those becomes heat island during night, which would add on, especially in the residential sector, it would add on to the cooling load in the nights.
Correct.
Can I add something to this? Um,
Yes, please. Yeah.
Regarding the first one regarding this satellite measurements or remote sensing measurements for UHA studies. Actually, those are very useful because I used most of these remote sensing measurements for all of studies actually, because you will get a whole picture of the city. Otherwise, you will have to have load of measurements in the city, which is practically impossible. You can have 2, 3 measurements or 5, 6 like that. And there is, I think, one project is going on in Hyderabad. They have 20 such instruments in different parts of the city, and it's it's run by actually NAR, I think so. So those kind of big infrastructure you need, like a load of instruments and load of efforts you need to cover the entire city. Otherwise, satellite measurements or remote sensing measurements are very useful for LSD and as well as for the images, like the change, land class, for example. We are taking this Landsat measurements or MODIS measurements, for example. And then you have also the indices, for example, NDVI, that's vegetation, and the WI is there for water. And there are some indices also helpful for delineating or differentiating the regions. So this all very important for UHA studies. And the second aspect, this cool island. we have to think about the temperature actually. It's not about the cool or hot. Okay. It's cool island doesn't mean that the temperature is very low. It's very cold now. We are just finding the difference between the city temperature and the rural temperature. So that means the rural temperature will be higher. That doesn't mean that city is it's a cold spot. There is a cold spot, but it's a relatively lower as compared to the city. So it should be there should not be a misconception about the cool islands.
Yes.
Thank you.
Yes. There are two questions in the chat box which are specifically asked for from Dr. Lily. The questions are first, the question is, so the recommendation suggested like changes in DCR by increase of building height with increasing setback areas. They are suitable for greenfield development, but in already heavily developed cities like Chennai or Kolkata, how does that work in that area, and what kind of methodologies would you suggest for your areas like these?
Sure. So basically for a new development like a greenfield development, this works very well. But the study what we did is for the dense developed T Nagar area. So we've been studying how the development of 2013 and 2019 vary. So there are, the moment FSI is increased, slowly the urban morphology transforms because nobody wants to everybody wants to convert that FSI into some kind of income. So slowly it would, maybe not today, it would definitely transform within the next 2 years. So then when that comes, I think these kind of regulation will definitely help in mitigating. But in certain places when that is not possible, then there are definitely, as Karthik was saying, trees on the, especially on the roads and streets would help in reducing the like improving the comfort and reducing the heat island. That is possible. So these tree covers on the streets and roads, which are basically public areas, the local development authority can take a call on that. But then when it comes to plotted area, it is always better when FSI is increased. Obviously, the slowly it would do it. It may not get transformed immediately, but definitely these conversion of concreted jungle into permeable surface would reduce the temperature significantly.
Yeah. Are there any last comments from any of the panelists who want to add something?
Yes, I'd like to have something on this tree and vegetation part.
Yeah.
Actually, most of our cities are not planned, so but they are expanding. And what we cannot do is whatever is there, we cannot change, but we can only modify. But beyond that, what's happening now, maybe we can do something about it. Planning where to extend, like first is vegetation parks, water bodies, what should be touched and what should not be. Like that, the policies are needed for that. Some policies are there, some are helpful, but action plans should be there and it should be city specific. And regarding the vegetation, particularly I wanted to emphasize that we can't plant some trees, okay? Just like we have to pick the trees, and it's very important. There are two aspects. Trees that will cool the atmosphere, the land surface, that will cool. And the second aspect is our cities are also polluted. So many trees are there, they are capable of taking pollutants, for example, PM, particulate matter. For example, ozone. That's very important for city like Delhi because the smoke there. You can't hardly see anything when there is a smoke. So ground level ozone is contributing to smoke. So this kind of tree selection or vegetation selection is also very important. Where you plant this and what you plant this and how much it can. And in some European countries, they have started this thing actually at the roadside. They're planting specific trees for getting the pollutants out like that. So when we are talking about vegetation, anyway, we are going to plant. So do that for a purpose. So that's an edge, an additional thing we can do. And I think we have to look for those kind of things for further development of the cities and parks or those kind of things. And
Yeah. To add it to not only native species, and we also need to consider leaf area intensity, the density of the leaves, because if it is too dense, it may even trap heat during night. That will also need to be taken care. So the leaf area density is another important parameter which need to be considered while selecting the trees.
Yeah, there are many other factors also. For example, another thing is the sequestration potential. The carbon sequestration potential is not same for all the trees or all the plants. So we can select, there are different parameters, we can check that, and then we have to do these kind of things. Yes, studies are needed or some homework is needed. We can't just go and pick some plant and put there. Thank you.
Correct. Anybody else has any last comments to make or offer? Souvanic, anything?
Just one point that we have to really look into the building practices which are very natural to a specific climatic zone and the ecological area. So now we are these glass retaining walls. The buildings are now multi-storied, and whether it is an office or apartment, they're using now curtain walls even on the western facade. So that is indiscriminate use of glass, really how much at the street level creates a huge contributes to the radiation and heat load. That is one thing I think. And the second one is, which generally we do not consider, is the contribution of solid waste to the heat, means the emission and the heat. That is now this hardly any regulation or management of solid waste in medium-sized towns. So they are just dumped on the openly on street, and so that is also leading to trapping of heat through not actually handling this solid waste properly. So that is also, I think, is important, making important contribution to the emission and to the heat, the trapping.
So thank you all very much for an exceedingly rich webinar, beautiful presentations, and I think have made very, very solid contributions to our understanding to the problem of UHI and the need to integrate considerations of urban heat, both into urban planning and development, as well as into climate action. And we need to marry these two in order to go forward, whether it is you're talking about urban development, you're talking about heat action plans, you're talking about climate change. You need to bring all these together if we want to address these problems, which we are seeing throughout this webinar. You see you see climate change and extreme rainfall, urban flooding, you're talking about urban heat. All these are interrelated issues. And if you tackle one, you also be tackling the other if you address the issue properly, which I think addresses increasingly. I'm getting the understanding that we need to have a national policy framework in order to integrate all these together. Otherwise, each city is trying to do its own bit in not a very concerted manner. And it will help both in building capacities, it will help in governance mechanisms, it will also help tremendously in finance if all these can be put together into a national adaptation plan also, which will also feed back into mitigation efforts. So once again, thank you all very much. Kirtibhai, if you've got some last words to say, I invite you to do so. Kirtibhai? I think he's left. Okay, so once again, thank you very much. It's been a real pleasure to have you all with us. I hope you won't mind if we are able to utilize your presentations in some form or the other in our work and for further understanding, at least for our own issues. We'll be in touch with all of you continuously in our efforts towards climate change, not only in Chennai, but climate change and interface with urban development across the country. Thank you all very much once again, and good night.
Thank you, sir. Thank you, everyone. Very
Thank
much.
you.
Nice meeting you all.
Bye.
Bye.
Bhumaji, did you get your photograph?
I hope so.
Okay.
You have taken.
Yeah.
Okay. Bye bye. Good night.
Bye. Good night.